three-dimensional space is a geometric three-parameter model of the physical universe in which all known matter exists. These three dimensions can be labeled by a combination of three chosen from the terms length, width, height, depth, and breadth. Any three directions can be chosen, provided that they do not all lie in the same plane. In physics and mathematics, a sequence of n numbers can be understood as a location in n-dimensional space. When n equals 3, the set of all such locations is called three-dimensional Euclidean space. It is commonly represented by the symbol. This space is only one example of a great variety of spaces in three dimensions called three manifolds. Details: in mathematics, analytic geometry describes any point in three-dimensional space by means of three coordinates. Three coordinate axes are given, usually each perpendicular to the other two at the origin, the point at which they cross. They are usually labeled x, y, and z. Relative to these axes, the position of any point in three-dimensional space is given by an ordered triple of real numbers, each number giving the distance of that point from the origin measured along the given axis, which is equal to the distance of that point from the plane determined by the other two axes. Other popular methods of describing the location of a point in three-dimensional space include cylindrical coordinates and spherical coordinates, though there is an infinite number of possible methods. See Euclidean space. Another mathematical way of viewing three-dimensional space is found in linear algebra, where the idea of independence is crucial. Space has three dimensions because the length of a box is independent of its width or breadth. In the technical language of linear algebra, space is three-dimensional because every point in space can be described by a linear combination of three independent vectors. In this view, space-time is four-dimensional because the location of a point in time is independent of its location in space. Three-dimensional space has a number of properties that distinguish it from spaces of other dimension numbers. For example, at least three dimensions are required to tie a knot in a piece of string. Many of the laws of physics, such as the various inverse square laws, depend on dimension 3. The understanding of three-dimensional space in humans is thought to be learned during infancy using unconscious inference, and is closely related to hand-eye coordination. The visual ability to perceive the world in three dimensions is called depth perception. With the space, the topologists locally model all other three manifolds. In physics, our three-dimensional space is viewed as embedded in four-dimensional space-time, called Minkowski space. The idea behind space-time is that time is hyperbolic orthogonal to each of the three spatial dimensions. Geometry, polytopes. In three dimensions, there are 9 regular polytopes, the 5 convex Platonic solids and the 4 non-convex Kepler-Poinsot polyhedra. Hypersphere. A hypersphere in 3 space consists of the set of all points in 3 space at a fixed distance or from a central point P. The volume enclosed by this surface is another hypersphere, but having a three-dimensional surface is the 3-sphere, points equidistant to the origin of the Euclidean space at distance 1. If any position is, then characterize a point in the 3-sphere. Orthogonality. In the familiar three-dimensional space that we live in, there are 3 pairs of cardinal directions, north-south, east-west and up-down. These pairs of directions are mutually orthogonal, they are at right angles to each other. Movement along one axis does not change the coordinate value of the other 2 axes. In mathematical terms, they lie on 3 coordinate axes, usually labeled x, y, and z. The z-buffer in computer graphics refers to this z-axis, representing depth in the 2-dimensional imagery displayed on the computer screen. Coordinate systems. In mathematics, analytic geometry describes every point in 3-dimensional space by means of 3 coordinates. 3 coordinate axes are given, each perpendicular to the other 2 at the origin, the point at which they cross. They are usually labeled x, y, and z. Relative to these axes, the position of any point in 3-dimensional space is given by an ordered triple of real numbers, each number giving the distance of that point from the origin measured along the given axis, which is equal to the distance of that point from the plane determined by the other two axes. Other popular methods of describing the location of a point in three-dimensional space include cylindrical coordinates and spherical coordinates, though there is an infinite number of possible methods. See Euclidean space. Below are images of the above-mentioned systems. See also, 3D printing, three manifolds, dimensional analysis, distance from a point to a plane, skew lines distance, three-dimensional graph, two-dimensional space, references. External links, the dictionary definition of three-dimensional at Wiktionary, Westerstein, Eric W., Four-dimensional geometry, MathWorld. Elementary linear algebra, Chapter 8, Three-dimensional geometry Keith Matthews from University of Queensland, 1991.